Good day and welcome back to part 3 in our series dealing with lines and planes. So in this third video, what we'd like to do is just cover one more example dealing with lines and planes. And this would really be where we are finishing kind of our first day of class um, if we were meeting face to face. And also at this point, I would be taking a break from talking and asking you all to spend some time, turning your desk, working with your neighbors, discussing these problems. So what I'd like you to do is pause the video and see if you can work through this. And the thing I would strongly encourage you to do is to draw some generic picture kind of representing the situation. It does not need to be specific, and you probably don't want it to be specific. Okay, so assuming we've paused this for a while, in order to find the equation of a plane, we need two quantities. We need a point, which we have, and we need a vector normal to the plane. So we want to find the equation of a plane through a point which is given and parallel to another plane. And furthermore, once we have that, we're going to find some points on the plane. So to get started, let me draw a very generic picture. So if I have two planes that are parallel to each other, so I'm not trying to be accurate at all, I'm just drawing two parallel planes. Maybe we're thinking, for the sake of this picture, z equals 0 and z equals 2. What I want to note is that if we know a vector normal to one of the planes, that same direction, if we were to extend this, is also going to be normal to the second plane. That is to say, if we know a normal vector for one plane, we could use that same normal vector for the second plane. The normal vector simply represents a direction perpendicular to the plane. And if we go back to the observation we had that was a key observation in that second video, whenever we see an equation of this form, we should immediately recognize this as a plane, and by reading off the coefficients of x, y, and z respectively, we have the normal vector of the plane. So that would be 2, minus 1, 3. And that immediately will give us the equation of the plane that we need. So let me go ahead and just make a few notes here so that we're all on the same page. So if two planes are parallel, their normal vectors have the same direction. And also something else I would like to strongly encourage you to do is whenever you're working through these problems with lines and planes, attempt to draw a picture. Sometimes it might seem silly, it may not seem like we take away or we get all that much from the picture, but other times that intuition will be just invaluable. So draw a picture, a generic representation. So the equation of our plane then is we have the normal vector given by 2, minus 1, 3, and the point on our plane is minus 2, 8, and 10. So we have x minus a minus 2, so plus 2, y minus 8, and z minus 10. And this would represent the equation of our plane. Now in terms of getting 3 points on the plane, that was the follow-up question. Well, working with the equation in its current form, I don't know that it's necessarily convenient or efficient to try to find those points, but what we could do is maybe kind of distribute and expand everything out. So we could expand this out and think 2x minus y plus 3z, and then we'll have 2 times 2, which would become a minus 4 on the right, excuse me. We have a minus 1 times minus 8, which becomes a minus 8 on the right, and a minus 30, which becomes a plus 30 on the right. So I've simply distributed out the 2, the minus 1, and the 3. I've left the terms dealing with x, y, and z on the left, and I've thrown the constant terms to the right. And this gives us 2x minus y plus 3z is equal to 18. And what I would like us to think about here is how can we come up with 3 points on the plane, or even as a starting point, a single point on the plane. That is a triplet of points, x, y, and z, that satisfies this equation. And the kind of analogy or the intuition I want to give you is if we were sitting in a pre-calculus class and I asked you to find the 2 simplest points to deal with on a line, you would probably almost immediately go to those intercepts. Where does a line intersect the x-axis and the y-axis? And that's exactly what we'll do here. The 3 simplest points might come from finding those intercepts. Where does the plane hit the x, y, and z axes respectively? So the x-intercept would correspond to y and z both being 0. The y-intercept would correspond to x and z being 0. And the z-intercept would correspond to x and y being 0. And now by investigation, we can easily come up with those remaining values. For example, if y and z are 0, 2x is equal to 18. So by inspection, we can say x is equal to 9. Similarly, if x and z are 0, minus y equals 18, so that y is minus 18. And if x and y are 0, it's 3 times 6, which will give you 18. So common points on a plane would correspond to the x, y, or z intercepts if the plane happens to intersect those axes, because note it doesn't always have to. So that finishes up our discussion for this video. In the next video, we'll kind of review the concepts of lines and planes and look at an additional example. So stay tuned and take care.